Hello all, hope you all are doing good. In today's class, we are going to learn recovery and atomicity and then recovery with concurrent transactions. Recovery and atomicity. Database recovery means recovering the data when it gets deleted, hacked, or damaged accidentally. Atomicity is must, whether its transaction is over or not. It should reflect in the database permanently or it should not affect the database at all. So firstly, let us move on to the properties of the transaction. Properties of the transaction contains atomicity, consistency, isolation, and durability. And atomicity says what? The execution of the transaction must be completely done or it is not done at all. That means if the transaction execution has aborted or failed, then in that case, the operations made by the transaction must be completely rolled back, ensuring the consistency in the database once after it is recovered. Now, here we are going to discuss how the database management system is going to recover the state of the transaction once the crash has been occurred. It is going to maintain the following information. First one is it should check the states of all the transactions which were being executed. Firstly, if there occurs any failure with some transaction, during that transaction failure, if there exists any other transactions that are running concurrently with the failed transaction, after the system has been recovered from the crash, the database system should also check for all the other transactions which are under execution in parallel to with this failed transaction. It should know the state of all the other transactions. And next point is a transaction may be in the middle of some operation. The DBMS must ensure the atomicity of the transaction in this case. If there is any transaction which is not completed the execution, then after recovery, the database system should ensure the atomicity property. That means it has to roll back the operations made by the transaction, which is in the middle of some operation. The third point says that it should check whether the transaction can be completed now or it needs to be rolled back. After recovery from the system crash, the system has to check whether the transaction can now complete its execution successfully. If not, it has to check whether there is any possibility of rolling back the execution of the transaction that it has made so far. And next, no transactions would be allowed to leave the DBMS in the inconsistent state. This thing we know. Recovery management component should always ensure consistency in the database management system by allowing concurrent executions without any conflicts. It has to ensure consistency in the database. Now, we are going to see different techniques which will allow the database management system in recovering and also maintaining the atomicity. So let us see what are those techniques. Firstly, we have log-based recovery. Log-based recovery is what? Every of the transaction when it is under the execution, the database system is going to maintain a file called log file. So log file is a file which contains the information about the operations made by the transaction, the time at which it has entered into the system, to the time at which it has completed the operations onto the particular data item. All such sort of information is updated in the log file. So once a transaction reaches the commit state, the log file related to that particular transaction will be deleted. If in case there occurs any failure, then the system can use the log to restore the database to the consistent state. So you can know in much detail about log-based recovery and the shadow paging, which we have discussed in the implementation and atomicity video lecture. Please go back to that particular lecture and find in more detail what is log-based recovery as well as shadow paging technique. Firstly, let us see what is checkpoint. It is a mark point where all the previous logs are removed from the system and are stored permanently in the storage disk. See, here we have a simple diagram. Here there is a point called checkpoint. So before to these checkpoints, the transactions, all the operations that are made are recorded into a log file. So all the log files before to this particular checkpoint are removed, and where they are stored permanently in the hard disk, which means whenever I say that the log record or a file, log file of a particular transaction is removed or deleted, it means that all those transactions has successfully committed. Thereby, the log files for that particular transactions are no longer needed, and hence they are removed and they are stored permanently into the storage disk. That is our first point. The log files before checkpoint will be removed and the data will be stored in the storage disk. When a checkpoint is reached, updates are saved to the database and the log is cleared. Okay. So when the transactions reaches the checkpoint, all the updates that are made will be saved to the database and the log file will get cleared or it is removed. Now, after the checkpoint, if there exists any transactions, if there exists any transaction at this particular point, if there occurs any failure, then it is not required for the database system to roll back all the operations. It is enough that the database system can roll back the operations made by the transactions till this point, that is called checkpoint. Now let us understand in more detail by taking an example. Here, what happens without checkpoint? Assume that there are number of transactions that are concurrently executing with each other. In this diagram, I have shown you with only 4 number of transactions. But on daily basis, there exist some thousands and thousands of transactions that simultaneously execute with each other. At some point, if there exists a failure with one transaction, then all the transactions before to that, multiple transactions, has also to be rolled back. So thereby what happens? It is a time consuming process. Also, redoing of unnecessary transactions. There may exist more transactions which are almost completed, or some transactions may complete its execution only due to some cause of failure made by one transaction. There is a situation that all the transactions before to that has to be rolled back, so that you can understand by seeing this example. In the example, we have 4 different transactions which are concurrently running with each other. And if a failure has occurred with this fourth transaction, then all the transactions which are in parallel to this T4 transaction, that is T1, T2, and T3, operations made by these 3 transactions along with the T4 has to be rolled back, or it is a time consuming process. This kind of disaster is caused without using the checkpoints. Let us see what happens if we make use of the checkpoints. Here you can see T1 transaction, T2. Here you can see the transactions T1, T2, T3, and T4. T1 started its execution, completes all its operations, and assume that it has reached to the commit. Commit indicates successful execution of the transaction. Once it has reached to the commit, we are placing a checkpoint here. Checkpoint is what? It is a technique where the database management system will periodically take a snapshot of the current state of the database and updates all the changes to the hard disk. Clear? So after this T1 transaction has completed, we are placing a checkpoint. And now we can see T2, T3 and T4. All these are running concurrently with each other. Now from this log file, you can see that T2 transaction has started its execution and T2 finished its execution and reached to a commit state. Similarly, T3 started and reached to commit state. T4 started, but it has not reached to the commit state. So assume that there is a failure that has occurred when T4 is under the execution. So then what happens? When this particular transaction has to be recovered from the failure, the database system should roll back the operations made by the transactions in parallel with this T4 transactions. That means now the transactions T1, now the transactions T4, T3 and T2 has to be rolled back. But the system will not roll back the T1 transaction as we have placed a checkpoint over here. If we could have placed one more checkpoint after completion of T2 commit and after the completion of T3 commit, if there occurs a failure of T4, then in order to recover the state of T4, the operations that made by the T4 will be undone and the execution of T4 will be restarted again. If checkpoints are placed periodically by the database system, then it is helpful for it to easily or within no time, it can recover the state of the failed transaction by knowing the updated value that it has made in the log file. By taking that values or the data from the log file, it can restore the data into the database and start the execution of the failed transaction and maintain the database in the consistent state. Now let us see recovery using the checkpoint. Here we have some points which are listed. Here you can see redo and undo lists are maintained. So which all transactions fall under redo and which all transactions fall under the undo list. Let us see. If the transaction have the operations like tn start and tn commit together or tn commit alone, then the transaction will be stored in the redo list. Which all transactions contain the start as well as the commit, start and commit, or if there is any transaction only with the commit state, then all those are stored in a list of redo. If there exists any transaction whose operations are like tn start but not tn commit, that means the transactions which are failed, then all those will fall under the list of undo. Now let us see this example and know which of the transactions will fall under redo and undo list. Here you can see T4 transaction has started its execution but has not reached to the commit. Okay, here there is a failure. After failure, it has reached to the commit state. Here you can see if the transaction contain operations like tn start but not commit, here T4 transaction has not reached to the commit state because it has faced with a failure. So in that case, the operations of T4 has to be undone. It has to start again its operations. So thereby T4 will fall under undo list. Coming to T3. Transaction T3 has started its execution and it completed its execution before the failure of T4. So thereby this particular transaction will fall under the redo list. And coming to T2. T2 transaction started its execution and it has committed its execution. That means completed successfully its execution before the failure of T4 transaction. Therefore, this particular operations of T2 will again fall under the redo list. And coming to T1. Transaction T1 has no start, but it has committed successfully. So it will fall under which list? It will fall under the redo list again. So this is what which we have discussed previously. And let us see the merits of the checkpoints. Checkpoint accelerates the data recovery process. Yes, it speeds up the data recovery process, unlike log-based recovery process. In log-based recovery process, if there is any system crash, the database system will look for the entire log file to know the state of the transaction where it was before the failure. So that it takes a long time. Second one is checkpoint records in log file avoid irrelevant redo operations, which means what? Unnecessary duplicate operations can be avoided if the checkpoints are placed. Next, checkpoint help in getting the transactions back in the case of accidental shutdown of the database. Transactions are executing during the process of execution. If there is a sudden shutdown of the database, then what happens? After it has been recovered or if the transaction is restarted, the database system will look for the checkpoint. The checkpoint will simply help in the track of the state of the transaction. Thank you.